Hey, hi YouTube, how are you? I hope you all guys are doing great. In this video, we are diving into system design from zero to million users. Giving the whole aim is to give you a big picture overview of how to build a scalable system. I will share uh, with you through a story. So basically, we will take Bob as our main character who is going to start a clothing brand from scratch and aims to grow it to 1 million users. As we follow his journey through a story, we will touch on important system design topics like cache, CDNs, data centers, and many more. This won't be a very deep dive into each topic. I will explain you a bit about each and every topic, but it is more rather an overview to spark your curiosity. So that the goal is to give you a framework that helps you connect the dots and motivates you to explore these concepts further, and you can dig deep into these concepts further. So let's start. So basically, I have created a simple deck for you so that you can also go through it. Uh, so, so basically, we have a character as Bob. He has an idea of opening a clothing brand. So currently, he has no idea on how to scale a system, but he's exploring all these things day by day. So each slide is for him for is like a day one, day two, day three. Okay. So he's trying to open a basically a clothing brand. So first of all, he went through internet and he got a picture like this. So he learned about this single server setup. So in single server setup, what happens is basically we have the users, they can use their laptop or their mobile and they have DNS. They don't have, basically we have DNS. Okay. So DNS is like stands for domain name system. Its job is to translate human friendly names like google.com into machine friendly IP address. Like it can be anything 142 point something because your browser and computers don't actually understand google.com because it's in English. They need something in numbers. So they need an IP to talk or connect to the server. So without DNS, we will be typing numbers, okay, into the address bar. So either you can type the IP address or you can type the bobcloths.com. Both are same, okay. But generally we don't do like that. So first of all, what how this flow happens in this single server setup is so this is the user or the client side, and they send this address to the DNS and it gives us the IP address. And then this IP address is sent to the servers and we fetch the HTML pages. So user access the website through the domain name such as popclass.com. Usually the DNS will basically it's a paid service to provide third parties and not hosted by our servers. So IP address is returned to the browser or the mobile app. Okay, so once the IP is obtained, so through the any protocols like HTTP, hypertext transfer protocol, these requests are directly sent to your web servers, and the web server returns the HTML pages or JSON response for rendering so that you can see the website here. Okay, so this is what actually a single server setup looks like. Okay, and what actually web application is? Web application is it uses a combination of server-side language like Java, Python to handle business logic or storage, and client-side language like HTML, JavaScript, which are used for presentation, whatever you see in the on your website screen. Okay, but what runs on the backend is written in Java or Python or any other language. Okay, so this setup looks good, very good to Bob. Okay, he is like very happy about this single server setup. But now problem occurs like as his business grow, he needs to also store about the user who is buying that cloth, from where he's buying the cloth. So he need to store that data. So he went through internet and then he read about database. So in the next setup, he also added a database. Now, what is database? Database is basically a place or a memory where, or a secondary memory, or it can be also primary, where you store your data. Okay, so now he was in a confusion that which kind of database should I select? He read about relational and non-relational. So let me explain you what two these two different things are and when you should choose which one. So when selecting a database, you can opt for either relational, which is SQL database, or non-relational, which is NoSQL database. So what is the difference between both? So relational database are also known as RDBMS. they store data which is in structured form in tables with row and columns. They support powerful SQL queries, including joins across multiple tables. So you might have also heard about popular relational database like MySQL, PostgreSQL, or Oracle databases. Non-relational databases, or you can call it as NoSQL DB, store data in more flexible format and are typically organized into different types like key value pair, graph, column, or document kind of thing. Okay, you might have also heard about Neo4j, Cassandra, this or Amazon DynamoDB, which is much more famous. So this database generally don't support joins and all. Okay, where when you should choose relational database when you have a structured database, when you should choose non-relational database when you don't have any structure. Is there any advantage of using relational database? Yes, they are like around 40 years till now. They are existing in the market. They are bottle tested and work well for most traditional applications. But when to consider non-relational database? When your data is unstructured, when you want ultra low latency, and your main goal is simple like serialization, deserialization, you need to store massive volume of data, then definitely you should use non-relational database. So Bob has now upgraded to a single server setup with some DB. Okay, he can choose anyone. So for now, let's suppose he used SQL DB. Okay, now just taking a pause, and I want to give a very basic idea about scaling. Definitely, we are going to cover scaling at the end also, but now as we are studying about DB, so I want to just give you a basic understanding of scaling. So there are two types of scaling mainly. First one is vertical scaling, which we call as scale up. So adding more power to a single machine. Let's suppose you have a CPU with some specifications, some RAM, ROM. Now you are adding more power to that system. Instead of 4 GB RAM, now you are upgrading it to 8 GB RAM. So it's like upgrading your own laptop with faster CPU, more RAM, or you can say bigger SSD, HDD. Okay. So for example, like your database server is struggling, so you replace it with one that has double the RAM or CPU cores. So in this case, if you take this example, if Bob is having a lot of data, okay, and he wants to scale it because the current DB server is not able to handle it, then he has to scale it, okay, either vertical or horizontal. Now, what are the benefit of vertical scaling? It's simple to implement because no code changes, nothing is, no more redesign is required because just you are upgrading the same system, okay, the connection and everything is already built. What are the cons of it? Okay, what is the disadvantage of it is every hardware has a limit. You can't keep upgrading anything forever. Okay, scaling also usually means downtime because you are scaling the same system, so it also have some downtime. Okay, and it can also become expensive quickly because you are also having downtime, and also you are reaching to the hardware limit. Okay, it is not generally more preferred is horizontal scaling, which we also call as scale out. So adding more machines and distributing the workload among them. So now, like instead of just using this one DB, there is also a chance that we can have multiple DBs. So think like hiring more waiters in a busy restaurant instead of just training one to run faster. Okay, so like it's just a simple example like you are upgrading one instead of upgrading one database to a bigger one, you are deploying multiple servers and use load balancing or sharding. We will see all this thing, okay, because I'm going to again double tap on this vertical and horizontal scaling. What are the benefits of vertical scaling? It's theoretically unlimited growth because you are not reaching to the hardware limit, you are just adding more systems. So it's like it depends upon your pocket, okay, just you are keeping adding more nodes. Okay, more fault tolerance because if one node fails, if one DB fails, it can route to another one, and easier to handle sudden spikes in traffic also. What is the disadvantage of it? Usually requires application change to support distributed system, more complex to manage. Okay, these all things. So currently, if you see Bob's conditions, we have the single set server setup, but with a DB. So now he can take the take the order, he can process it and do it whatever he wants. Okay, he can also store it. Now, Bob's business was working pretty fine. Okay, and he was having lots of users. Now, suddenly he felt that the users are growing in an enormous number, and he's facing a problem that the server, every server has its own capability, it has its own limitations, you can say. So he thought, can I upgrade to more servers to increase my response times, to decrease my latency, to have a much more faster system? Okay, so then he went to internet and he learned about load balancer. So what actually load balancers are? It, like here you can say, in this setup, users connect directly to the public IP. Okay, see, we have a user. They are basically through the DNS. This system is this setup is same, that he's sending the URL and he is getting the IP address. Now this load balancer will be directly connected to the client will be directly connected to the IP, public IP of load balancer. Okay, because of this, the web servers themselves are no longer exposed to the public, because initially, if you see this setup, the servers were basically this client was directly accessing the servers through their public IP, but now this is not the case. They will just connect to the load balancer through this public IP. For security, the communication between the load balancer and the web servers happens over the private IP. Here you can see we have the private IPs. A private IP is only accessible within the same internal network and cannot be reached from the internet. So, like, the load balancer receives requests from the user and forward them to the web servers via private IP. If one server goes down, like let's suppose this left side server goes down, all the traffic is automatically redirected to the other server. This keeps the site online every time and it gives a good uptime. And if suddenly traffic spikes, you can simply add more servers to the pool. The load balancer will automatically start sending requests to them, keeping performance smooth. So it is balancing the load simply. Who is creating that load? This client is creating that load, and this load balancer is basically a function which is balancing the load. Okay, and it is sending to different servers. Okay, with this setup we solve the no failover problem, so it will never fail. Okay, and boost the availability and scalability of the web tier. Okay, um, you can we can also use multiple load balancer. Okay, if you want high available setup, you can run two or more load balancer, often in different availability zones or data centers. One is active. If there can be chances like one of the load balancer can also fail, so that's why we want multiple load balancer. One is active and others are on the standby, or they can call be in active mode with some configuration, or a virtual IP or DNS failover automatically redirects the traffic to a healthy load balancer if one fails. But for now, in this video, we are not going to talk about multiple load balancer. Just we are taking as just one load balancer is enough to handle it. Okay. So now this setup looks better than previous, because now our servers are not directly exposed to the client, and we also have load balancer. We have added more servers so that we can handle more number of requests. It is more scalable. It is like more available. We are increasing the uptime, and latency will be also decreased because now we have multiple servers, so the speed will increase. Okay, now but this is the same thing, it can also happen with DB, because DB server is only one. There can be a chances that the way we upgraded the server from one to many, we have to also upgrade the DB server, because if a server, and lot of time we have to read the data, because for clothing.com, where the data of uh, cloth will be stored, like the price, the name, the description, where it will be stored, it will be stored in server. So there are lots of read operations here. So we need to upgrade the database also. So now this is how our current setup will look like. So there is a concept called database replication. Basically, let me explain you what this database replication means. So this, we call it as master and slave relationship, or master or slave DB setup, where master handles all the write operations like insert, update, and delete. The slave databases are read only. So they copies the data from the master and keep in sync through the replication. They're replicating it. Okay. Since most of the applications perform more reads than writes. So in Amazon also, mostly you see the things. Okay. like out of 100, just one or two you place the order. So placing the order is the right operation. But you consume the things in Instagram. You consume the things more than posting the things. Some people don't even post in their whole lifetime, but in a day they are seeing 100 or 1,000 reels or the posts. So read operations, mostly systems are read heavy. Okay, so that's why we have created three different slaves, and whenever the server has to read, they can read from anyone. Okay, so if we just have one DB, the read operation will slow down. Now we have three different, so basically it can route, yeah, and we can just read from any one of the slave. But we will only write into the master one, and once we write into the master one, it can copy the same thing through database replication into this all the slaves. Okay, why we use database replication? For better performance. The master focuses on write while read requests are spread across the slave. This parallel processing allows the system to handle more queries at the same time. Reliability is another factor, because if one database server is lost, let's suppose one database server is lost due to disaster like flood or earthquake, anything, your data is still safe because the same replica is also present in another slave, in another server, in another region. Okay, high availability, because even if one database goes offline, your application can keep running by reading from another replica. In short, replication makes the database safer, faster, and more resilient, you can say. If there are also cases like, if there's only one slave database and it goes offline, the system will temporarily direct read operations to the master. Okay, let's suppose we have one master and one slave. If this slave is off, then it redirects it to master also. Once this issue is resolved, a new slave is also can take place and resume the replication. If you have multiple slave database, it is even simpler. Read requests are just routed onto the healthy slaves. Okay, the fault tolerance or the faulty one is replaced with a new server to keep the replication going. Okay, but looking at the setup, you might think that, what if this master is gone? Okay, so what happens if master goes down? Okay, this is the main question. So once the slave, once the master is goes down, so one of the slave will be promoted to the master, because all have the same data because they are in the sync. Okay, so it will handle now all the master operations, the write operations. At the same time, a new slave will be created to maintain the replication. In real world production system, this process is more trickier. Okay, because a slave might not have absolute latest data, or there can be other situations also. In that case, data recovery scripts are run to fill any missing record before the system is fully back to normal. Okay, but definitely, because I am telling you that this whole video is to create a curiosity and to link all the dots. Basically, replication in itself is a very big topic. Load balancer itself is a very big topic. But before knowing this, you should watch this video so that you can have a curiosity. Now you have the curiosity that, okay, what if the master fails? How this data recovery scripts are running? So that curiosity can be built through this video. So that's why I'm telling you, I'm making this video. And definitely, if you know the even if you know these topics, it's a very good thing for your journey, wherever you are starting in this um, system design journey, or maybe you are trying to switch jobs or whatever. Okay, but generally, go through this for your curiosity. If you are good in your field, if you are have that particular curiosity, then everything comes to your door. Okay, so now it looks very perfect. Okay, we have good servers, we have good database, load balancers, everything. Okay, but now, he one of the friend told him that you can to Bob, that you can also speed up your website performance by using some cache. Okay, so now something suddenly came into his mind, that cache is the thing. Okay, now he went through internet and he explored about cache. So let's see how actually this cache works. Okay, the cache tier sits between the application and the database. Okay, the whole application of the server and the database. It is much faster than the database and can be also scaled independently. You can also scale this database independently, and you can also scale this cache independently. Uh, Basically, how this read through caching process looks like. So the web server checks if the cache has the data. Let's suppose someone is asking some
maybe price of some product, or maybe description of some product. Okay, let's suppose you are watching, you are going to Amazon, and you are like, out of 10, 8 times you are just seeing a particular watch. So every time they don't have to go to database, they can store that particular thing in cache memory only. Okay, so you go to the web server and you are saying that, okay, show me the description of this watch. So the web server check if that data already exists in cache or not. If it is there, it will return to the client immediately. If not, the database is queried and the result is stored in the cache, and then it is sent to the client. Like other caching strategies exist depending upon your data size, type, and access pattern. Okay. Now, what should we consider when we are using a cache? When to use a cache? Okay. First, the most important thing is we should use caching when data is read frequently but update rarely, because uh, in cache it is a small memory, you can't store everything. Okay, so because it is a volatile memory. So let's suppose you want to write something and just you wrote something in the cache, and suddenly it's a volatile memory, and let's suppose the cache server restarted, now whole data is lost. So it's important that data should live in persistent storage. Okay, so that's why whenever you are having a read frequently things, then you should use cache. You should also focus on expiration policy, because every whatever data you have stored in cache, we call it as cache data, should have an expiry time. Too short is not even too short, not even too long is good, because too short will you will be hitting the database more often. If it is too long, then you have a risk of serving the stale data, the old data. Okay, and so, and also consistency also the thing that makes sure your cache and database are in sync, because this can be tricky, because if the data gets updated more often and you have an old description, and this is not a good thing, especially when scaling across the region, because writes through the database and cache aren't always in the same transaction. So this is also one of the challenge. Okay, then also avoid single points of failure, because a single cache server can take down your whole system if it fails. Use multiple cache servers across data centers and consider over provisioning memory as a buffer for growing usage. And you should also have a eviction policy, because when the cache is full, because cache can also be full because it's not a very big memory. Okay, so old data must be removed to make space. There are different common approaches like LRU cache, LFU, FIFO. There are different techniques to um, remove the um, or you can say to free up the cache memory. Okay, in short, cache speeds up your application, reduces database load, and improves scalability, but only if you choose the right strategy and plan for expiration, consistency, and redundancy. So cache is also really, really important to speed up your configuration, speed up your application. So now Bob has also added the cache layer. Now his application looks pretty good. Okay, it looks super easy, super not super easy, it's complex but super good. Okay, but now he faced a basic problem that some static things like images, HTML pages, JavaScripts, some scripts are not getting loaded very quickly. Okay, in some regions. So then he learned about CDN, or you can say content delivery network. It is basically a network of servers distributed across different geographical locations that delivers static content like images, videos, CSS, and JavaScript files. Also, there is dynamic content caching, where HTML pages are cached based on things like request path, query strings, cookies, or headers. It is a new concept. We can look into about it in a different video. In this video, let's focus only on static content and how CDN handles the static content. How CDN works? Okay, when a user visits a website, the CDN servers closest to them delivers the static content. The closer the server, the faster the load time. Because, for example, if a CDN server are in Mumbai and a user is in Pune, he will get the content more faster than a user sitting in any other Delhi or London, simply because the data travels a shorter distance in case of Mumbai to Pune. Okay, so let's see how actually let's focus on this part and how these things work in step by step. So whenever a user requests an image, let's suppose logo.png or whatever, okay, via URL from a CNN provider. Okay, so he's requesting for some URL. If the nearest CDN server does not already have that logo cached, it fetch it from the origin, means somewhere from the database. Okay, telling like which could be your web server or it can be Amazon S3, it can be anything. Then the origin send back the image along with the TTL, which is we call as time to live, for which period of time that image is going to live, and the file stays in the cache in the CDN until TTL expires. Okay, so the CDN stores that image and send it to also the user. The file stay cached until the TTL expires. So next time if you are, because let's see, in case of Bob, if you are watching a jeans, initially I took an example of watch, but let's suppose you are watching a jeans, okay, and you are trying to buy it, okay, every time you are coming and seeing some description and then coming back and forth, and every time just scratching your dreams, okay. So every time you are coming, so it's not a good idea to extract the genes image and all from the database every time. You can also store in the CDN with some TTL. And now in CDN also, let's suppose you and your friend. Now your friend is requesting the same image, the same genes image. So it this will at this time it's instantly served from CDN cache without hitting the original server. It will reduce the load on the server also, because a lot of time you might have also observed that the same advertise come in whole your gang. Okay, so you and your friend and some more, the whole group receives a particular advertisement, and most of the time maybe out of 10, 5 people have the same taste, so they go and click onto this popclass.com and they are seeing the same jeans. So instead of, for everyone, instead of hitting to the DB, they can also get it from CDN because it is cached there. Okay, so this is one of the benefit of CDN. But we should also consider something when we are using CDN. First one is cost. First one is cost, because CDN are run by a third party providers and charge for data transfer. Storing rarely used files on a CDN offers little benefit, so keep those on your origin only. Cache expiry. So for time sensitive content, set an expiry time, which we call as TTL, not too short, not too long, uh, to have a good budget of it. Okay, to have a good, you should not fall over budget. Then CDN fallback, plan for outage. Even if the CDN is temporarily down, your website should redirect or detect the problem and pull direct content directly from the origin, because everything can fail in this world. Okay, invalidating files. So to remove a file before it expires, use the CDN providers to invalidate APIs or use object versioning. For example, um, uh, for the same product, you have a different version in your origin, but your CDN is having an older version. So you can also invalidate through these APIs. Okay. So again, definitely you can learn more about CDN, but this was a basic idea about CDN, so that how it can increase your speed of the website when in terms of delivering the static content. Okay. So now it again looks perfect. Okay. So we have CDN, we have caching, we have database replications, we have multiple DB servers, we have multiple web servers, we have DNS, load balancers. Looks very, very perfect. Okay. So now I want to go through a topic which is stateless architecture. Okay. Before moving to another thing, I want to explain you about stateless architecture, which is really, really important. So I have created a diagram where you can see on the left hand side, we have stateful architecture, and here we have stateless architecture. Okay, when it comes to scaling the web tier horizontally, one of the most important steps is to move the state out of the web servers. Okay, what state means? State means something like user session data. Okay, instead of storing the data inside a web server, we keep it in persistent storage, such as relational database, NoSQL database, or in-memory store like Redis or Memcache. This design is called stateless web tier. Okay, so a stateful server, which is on left side, remembers client data between requests. So user one made some request, so his session will be stored here. User two made some request, his data will be stored in this second server. Okay, so if a user A, or you can say user one, session data and profile image are stored in server one only, then all of the users one request must go back to server one only, because His data, everything is in server 1 only. So how server 2 will handle it? It will not able to handle it. If the request accidentally goes to server 2, authentication will fail because server 2 doesn't have user A session data. Load balancer can handle this sticky sessions. So it can remember, like, I have to send the load balancer can remember that for user 1 I have to send to use server 1, and user 2 I have to send to server 2 only. But it also makes it harder to add or remove servers, or like the routing becomes harder. Okay, for load balancer also, it becomes an overhead for him. Okay, and now what this stateless architecture looks like, instead of storing user 1 session data into server 1, or and user 2 data into server 2, we store it into a common storage, secondary storage, like a NoSQL. Instead of all state, so a stateless server, doesn't store any client session data locally. Okay, instead of all data lives in a shared data store outside the web server. Now, any request from any server can send to any web server in the cluster. So now user 1 can be sent to server 1, server to any server. Okay, because the data is stored in NoSQL, it's in a common area. Okay, so there is no problem of authentication and such thing. Now, any request can be sent to any server, and server just fetches the data when needed. This makes the system simpler, robust, and far easier to scale. Okay, and why stateless makes scaling easier, you might also be having a feeling of it, because now we don't have an overhead to filter out which request should move to server 1 or server 2. So once you have moved the session data out of your web tier, auto scaling becomes simple. You can add or remove web servers automatically based on your traffic. The shared data store, which is often NoSQL for easier scaling, ensures all servers see the same session data. So, and if your website starts growing internationally, you can also even deploy into multiple data centers. This improves availability and delivers faster, more reliable user experience for users all around the globe or the world. Okay, so currently our system looks pretty good. Bob has also learned about stateless architecture and stateful architecture. Definitely, stateless architecture is much better because all the session data and all are stored in central system. So we don't have to validate. We don't have to send user 1 into user server 1 only. We can send to any server because the lookup table has been brought out. Okay, it is out of the picture now. We are not storing that data into the server. We are storing into a secondary storage. Okay, so it's pretty good. Okay, so this is the current system. It looks like we have DNS, we have CDN, popclus.com is booming up, we have load balancer, we have DB, we have NoSQL, we have cache, everything is working fine, we have multiple servers and whatnot. But now suddenly, Bob's business is growing so good that even around the world, in other countries also, there is a demand. Okay, so now how we can scale it? Now here comes the concept of data centers. Data centers is like, once your user base become global, you need lower latency for user in different regions. Because if you deploy your website in India and some of your user are in Africa or US, then how they will not have that particular latency, because they will have higher latency, because anyway it is traveling through physical wires only. Okay, so lower latency for users in different regions. You want high availability in case of one region fails, or disaster recovery capability you want. So you deploy the same application into multiple geographical location. You have to focus here. Okay, this is the same thing. The box which is inside the dotted line is the same thing. This is the same thing. Okay, so only we have replicated the system twice, and one data center is in, let's suppose, Asia East, and one is in Asia North. Okay, so now, if people are accessing from Asia North, they will go to data center 2. So they will offer a low latency. If people nearest to Asia East, they will get this data from data center 1. And this is basically done by geo routing. Okay, so in this way, they will get lower latency, and definitely this session will be stored outside. Why? Because if, let's suppose, user 1 came to and suddenly it went to yeah, it accessed the Asia East 1 servers, and his authentication data is in no is in this server only, in the left side dotted box. Maybe in the next time, if this Asia East 1, this data center 1, goes down due to some disaster, and suddenly it redirected the user to data center 2, then if, the server will say that, okay, no, I don't have user this user data because this session data was inside this left block in the data center one. So that's why, to make it more future proof, we extract this NoSQL or the session things into outside the data centers to make it more data less architecture, because this was the whole idea of data less architecture. Okay. So how these users are routed, so that is done by GeoDNS. GeoDNS means DNS that resolve the domain to different IP address based on where the request comes from. So let's suppose the user is from New York, DNS points to US East. Okay. If someone is from San Francisco, someone, so DNS will point to West. Okay, so the benefits are users connects to nearest data center, so it will have less latency. Traffic can be balanced between data centers also, but definitely it has some challenges. It doesn't looks it looks good, but it's not that simple. Okay, so data DNS has caching TTL, so failover isn't instant or something. So there can be also failure scenarios which can be handled. Like, let's suppose we have two data centers. Okay, one is in uh, normally US East gets 60% traffic, and US West, or you can say Asia East gets 60% traffic, and Asia North gets 40% traffic. If there is a failure that this Asia East goes down, so all the traffic is coming to Asia North. Okay, so in case of failovers, it can be helpful to switch, because one thing is you are getting more latency, that is fine. Second thing is you are not even able to access the website, that is much more you can say much more disastrous. Okay, so this failure scenarios also can be handled. Now, there are some key challenges like traffic redirection, GeoDNS for location-based routing, which is a challenging thing. Data synchronization should be there, because hardest part of multi data center design is the database synchronization, because each data center has its own database, so you have to keep them in synchronization. There are different kind of strategies like synchronous replication, asynchronous replication. Okay, for Netflix, I was reading somewhere that Netflix uses asynchronous multi-region replication. That's why it offers very low latency. Testing and deployment is also a challenge here, because code and infrastructure must be identical in both the data centers. And for this, you can use CI/CD pipelines to deploy all to these data centers automatically. And you have to also simulate failovers and test it. Okay, but what are the advantages? Advantages are fast response time, because user is connecting to the nearest data center. Redundancy, once one of the data center fails, it another one takes over. Disaster recovery readiness are there. What are the disadvantages? Much higher complexity. We haven't seen data synchronization. Consistency should be there. Expensive to maintain multiple data centers, very expensive. Failover might cause session loss if it is not stateless, but hopefully, like luckily we have made it as tasteless. Okay, so that was the whole idea, to learn about stateful and stateless architecture so that we can help. Okay, so now our application looks perfect. So we have data centers, load balancers, and many more. Now there is also a concept called message queue. So, like, imagine your clothing website allow customers to upload custom designs on t-shirts, or request gift wrapping when ordering. These are time-consuming tasks that you don't want to block user checkout experience. So, example like your front-end service, which is collecting the order. Okay, when a customer places an order with a customization, your order services some publish a message to order customization queue, because we can have other services also, like custom design, request, gift wrapping, and all things. Okay, so there is an order customization queue with containing details like order ID, design, file URL, customization type. Now there is a message queue, which is a buffer. It stores this request temporarily so that they can be processed later, even if the workers are busy. There can be chances that other servers are already busy, okay, or maybe sometimes offline. But this message queue will keep that thing. Okay, now the consumer, which is other worker service, special backend service, pick message from that queue. Like there can be a print service which downloads the designs and sends to printer. Gift wrapping service, fetch is the gift wrap details and prepare a package. So in this case, why it is really helpful? It is useful because if the demand spikes during like a Diwali sale, you just add more customization workers without touching the checkout code. If customization worker crash, orders are still stored in the queue. They are not lost. They can be processed later. Okay. So this is how message queue helps. Okay, and definitely both centers, data centers are copy. So this is how message queue helps. Okay, there are different types of queues, Kafka, RabbitMQ, what different types of queues are there. We can explore more about it. But this is just to have a feeling of why queues are helpful, so that you don't block your main service because of some uh, another service. Okay, because checkout is really really important. Who don't want cash? Okay, but print and all can be also delayed, not delayed, but it can be it should not block your experience. It is not like that you have placed an order and until it is not wrapped, it is until you have not designed the t-shirts, you are not able to check out. You can check out. Okay, so, and also other tools are there. So I have connected into other tools. Other tools can be like logging, so that you can check what logging is really, really important, so that you can have a centralized logging system, so that you can see what things are happening, which one is healthy, which is going wrong, and whatnot. You can also have some other tools like metrics, like you can see your business metrics, aggregated metrics, and whatnot. You can have other tools like automation, like try on AR feature and whatnot. Okay, so these all things are basically are considered in other tools. Okay, now if you see, the final architecture looks pretty good, and I'm damn sure that it can handle around 0 to 1 million users. It can easily handle 1 million users across the globe. Okay, because we have DNS now. Someone will add bobclothes.com, he will get an IP address, and then if basically the CDN will also give some data, so that for the static or dynamic content, it will caching is already there in CDN, because dynamic and static data can already come if it already exists. So it will give a better experience, okay, a fast experience. Then it will go to load balancer during geo router. It will move to closest data center. We have multiple servers, and we have also multiple um, DB. Here you are seeing shard, which I will explain you sharding. But for now, just think as a DB. Then we have cache, we have message queue, we have other service. We have also made it stateless because we have brought the session data into outside of this picture, and we have also other tools like logging, metrics, which are really really important to make the whole system healthy. Okay, now I want to come again. Sorry, I want to come again to the database scaling approach. Okay, so we have seen about vertical scaling. Vertical scaling means adding more CPU cores, increasing RAM user, using faster SSD storage, upgraded network speed. Okay, horizontal scaling, which we call scaled out, means adding more servers. Okay, when adding more servers, there is an important concept called sharding. Okay, I can create a separate video on sharding, but for now I have not prepared a PowerPoint presentation for sharding, so I can explain you. Okay, sharding means breaking one big database into multiple smaller database, and smaller database here you can see are called as shards. Okay, so how you can basically break it, because it's not that easy. Okay, it's not a solid thing. Each shard has the same schema but different data. Okay, so if in your database you have 5 columns, then all the shards will also contain 5 columns. Okay, now let's suppose you have 4 database servers: shard 0, shard 1, shard 2, shard 3. The rule is how you can divide it. Okay, what will be your sharding key? Let's suppose it's user ID, which is primary key, which is not duplicated. So what you can do, you have 4 shards, so you can divide it like user ID modulus 4. So if ID is 1, so 1 modulus 4, it will be 1 only. Okay, so it will move to shard 1. If your user ID is 2, 2 modulus 4, it is 2, so it will move to shard 2. Similarly, if the ID is 4, 4 modulus 4 is 0, so it will move to shard 0. Similarly, if you have ID as 17, so 17 modulus 4, it will remainder as 1, so it will move to shard 1. So this is how you can divide it. Okay, so all this um, all the IDs or user ID which are having remainder as 0 will move to shard 0, shard 1, shard 2, shard 3. There can be no other uh, results. Okay, because if you divide something, if you find modules by 4, it will range from 0 to 4 only. Okay, 0 to 3, I guess. Yeah. What are the pros? So no single server is overloaded because we now have multiple shards can also handle huge data volume and traffic because now the single database has been converted into different shards. Okay, but there are also some challenges which you might think. Resharding. So if one shard fails, or you can say if one shard fills up faster, uneven data distribution is there. So you must move data and change the sharding logic. Okay, so it should be fixed. So it should be a fixed, consistent hashing to make it these things easier. Also, there is also important problem which we call as celebrity on or hotspot problem. So if all traffic hits one shard, okay, so let's suppose in one shard we stored some data of Katy Perry or Justin Bieber, okay, and so this shard is having Katy Perry's data. So and who is a very huge celebrity. So now every data, most of the read data will come to this shard only, which will have a problem because it will it can be overloaded. So that's why we should put very popular user in a separate shard for further partition. Okay, we should not include into the local user shard because definitely they can overload. Okay, that's why server crashes. Okay, joins become hard because you cannot easily do joins across shards because um, all this data has been separated with some starting logic. Okay, basically what is the fix? So fix is denormalize data. Duplicate needed data into multiple places. You have to denormalize the data. Okay, so if you combine these two approach, some companies use it both like horizontal and vertical scaling. They start with vertical scaling, simple and cost effective because you have to just increase the capacity of your system. When the traffic explodes, they add sharding and all. Okay, sharding means horizontal scaling. Okay. So real examples can be Instagram. They started with PostgreSQL on a single machine, which is called as vertical scaling. When they hit 100 of millions users, they started sharded PostgreSQL by user ID. Popular accounts like celebrities get special handlings to avoid hotspot or the celebrity problem. Okay, and definitely this is the final architecture, and it can handle more around 1 million users. But if more than 1 million requests are you are getting, then definitely this requires more fine tuning. Okay. Um, I think I have forgotten to add API gateway here. So let me explain you what is API gateway. API gateway acts as an entry point or a middleman between client and your backend service, which often sits behind the load balancer. So this is the right place where you can add a API gateway. It routes the client request to appropriate services. Besides routing, API gateway typically handle important concerns like rate limiting to prevent abuse or overload, authentication and authorization to check who can access what, request response transformations like aggregating response from multiple servers, and caching, logging, and metrics are also done. So it's not just a simple middleman, but it's smart, centralized point of managing API security securely and efficiently. So this is one I think I missed. Except that I think for 1 million users, I think this much is enough, even if they are accessing through different geographical regions. So that's it. What are the takeaways? First, keep your web tier stateless. Second, build redundancy at every tier because anything can be lost. Cache data as much as you can. Support multiple data centers. Host static assets in CDN only. Scale your data tier by sharding, but first try with vertical scaling. Split tiers into multiple services. Okay, and monitor your system and use automation tools that we have seen in the tool section. So that's it for handling millions users. This type of architecture is perfect. So now what you can do is you can learn about all these things in deep, how message queue works, how data center works, how this stateless architecture in much more depth, how CDN works. But this, after seeing this video, you can have a basic understanding of your system design, and you can have a curiosity of handling more than million users. And definitely I can bring some more video on different types of system designs with taking some examples like creating some rate limiting, or maybe to design a user feed system, chat system, whatnot. But this is what can give you an idea or a curiosity about how we can handle million users. That's it. If you like this video, please hit the like button, subscribe button, and subscribe me for such more videos. Okay, so that's it. Thank you. Bye bye.